only about 10% of code from agents is both correct and secure. Some of our customers actually run Endor Labs basically headless. If you were a developer, you would have no idea you're using Endor Labs because it's fully wrapped into other systems that you're using. One customer in the financial services space that basically reduced their security ticket backlog by like 90% in the first day, right? They went from like, I think it was like 1,200 tickets down to like a couple hundred pretty much overnight.
All right, Andrew, welcome to Unsupervised Learning.
Thanks, Daniel. Great to be here.
Awesome. So I understand you guys are doing some really cool stuff over there. How would you describe the problem that exists and what you're trying to do to solve it?
Yeah. So Endor Labs works in the application security space. And so we kind of sit in between security teams and engineering teams. And historically, those are two groups that don't always get along. Developers need to move fast, and security is often there to put some brakes on what's going on. And so that's kind of always been the challenge. And I think the other kind of gap that has existed for a long time is that security took a lot of shortcuts to try to keep up with engineering. And so they kind of made a lot of guesses about what was actually risky. And so, we would actually end up sitting in some of these conversations between security and engineering as they're having arguments about what is actually a risk in the code or not. And that's a huge waste of everyone's time. That was kind of the problem that Endor Labs was designed to solve. That started in the open source space. So we were, even just 4 or 5 years ago, about 90% of application code came from open source. So that stuff, developers didn't write themselves, but imported to make their jobs easier because engineering, had become basically described as like Lego assembly, right? You take all the pieces and kind of build whatever you want to build. Anyway, at that time, all the products in the market basically looked at what was called the manifest file and made a guess as to what was in your application. And so if you've ever, baked a cake, you might cheat or substitute things in the recipe. It's not a great way to know what's actually there. And so Endor Labs pioneered a new way of actually assessing what is in that application that got rid of those shortcuts and actually gave evidence both of security and engineering about what risk actually existed in their application.
Okay, interesting. So is this ultimately rolling up into some sort of vulnerability management system? Is it going directly to the developers? Like, how are the developers actually consuming that?
Yeah, both. For security, they can obviously use our tool, or in some cases, they might roll it into their vulnerability management system. But for developers, it needs to show up where they're working, right? You don't want to go look at another dashboard. It needs to be in your IDE or in your pull request. That's where we typically show up for a developer. The other thing we pioneered besides this way of looking at code was actually the way we actually gave information to developers. And so, again, you have to kind of know the state of the industry. But at the time, people would open what they called like auto pull requests. And it was basically just a guess. I would say, there's this new version. You should upgrade. The best tools were like, well, 60% of the time it didn't break. You might be fine. Go ahead and try it. Because the way we did the analysis of the code, we're actually able to give the developers evidence that actually your code won't break. And so that also kind of changed that experience both for engineering and security.
Oh, interesting. Yeah, because that trust relationship between the security team and the engineering team is super critical.
Yes.
Yeah, I've run a number of these programs and it doesn't take long to burn the bridges where they just won't listen to you anymore. And so it's this weird political thing where the managers are talking to the other managers saying, hey, we really need your people to do this. But on the engineering side, engineering wins. They're going to win. They're going to win that, right? Because from the CEO down, it's about features. It's about the business moving, right? So I think enough developers complain to their manager, hey, I can do all this dumb security stuff all day, but it's just wasting my time and it's wrong half the time and it's causing me to not ship features. That means that engineering manager complains over the security and they're like, hey, I'm not going to do this until you sort this out.
Yeah. And the way this often shows up is we'll start talking with an organization about, what's kind of going on, what challenges are you having? And sometimes it's like, oh, our technology is fine, but we have an organizational problem. And then the job there is to be a little bit of a therapist and diagnose what's going on between security and engineering and why security is losing that credibility with engineering teams. And so, the big benefit that we give engineering teams, we started in open source, but this now applies to, first party code and containers as well. But we give you that evidence to actually have that informed conversation with engineering. So that's not a security said, engineering said. There's actually evidence in the code about how something can be reached and exploited by an attacker.
Okay. Yeah. So talk me through that. So what are all the different surfaces you're able to look at?
Yeah. So as I mentioned, we started in open source, so open source dependencies, and we pioneered there what's called program analysis, which is a form of static analysis that actually builds what's called a call graph of your code. So you can kind of imagine a map with all sorts of strings going everywhere, seeing how all your different functions are calling, down into vulnerable functions. And so we extended that now to first party code and containers as well. So we go from, the code that your developers wrote, we can trace, user input, data flow through all that down into your dependencies, and then now also down into the container image. And so we are the only company in the market that provides that sort of what we call full stack reachability across code, dependency, and container image layers. And so that includes other things like, secrets, AI models, all the different, supply chain pieces that your developers might integrate into their applications.
Okay, interesting. Yeah, to whatever extent you can share, like how are you doing all that? That seems like some of the secret sauce, but also the audience is very technical, so they like to hear details.
Yeah, so we're actually pretty transparent about how it works. I think you can find a lot of this on our docs or in our white papers on our website. It's changed over time. Now, it used to be just static analysis. Now it's actually a mix of agentic AI and static analysis. But the key thing when you build an agent is you have the LMM, everybody can use that, but then you have the tools you can give an LMM and the data. And so the way we kind of describe it, I can ask, an AI model to do a math calculation for me. It's going to burn a ton of tokens, and then it may or may not be correct at the end of it. If you've ever tried that, there's tons of examples of LMMs failing at math problems. But if I give an LMM a calculator, it works really, really fast. And so you can think of Endor Labs as that calculator to help an LMM understand code. And so we have a couple different kind of tools that LMMs use to parse code. So the first is code search. And we actually have a paper that's going to come out in a couple months because this is a brand new technology that our research team developed, but it's basically using a mix of hashing and embedding to kind of map and find patterns in the code. So that's kind of like the basic, we can search and find things in your application. The next piece is code navigation. And that's the part I was referring to earlier about the call graph. So basically we look at, we build a model of your application code. We see exactly, when data comes in, how you call, function to function through your code and then down into the dependencies. And then critically, we look at both direct and transitive dependencies, so the dependencies of your dependencies, and kind of build that graph. And then we use, when you build an application that gets compiled, put into a container. And so we use that information about the application layer to then look at how that application layer integrates with the, container runtime and operating system layers as well. So you kind of get that full code to, runtime reachability graph. And so that's how we're able to provide that like noise reduction. We're actually able to show you like with evidence how that code is calling into a vulnerable function, whether that's the code you wrote or code you imported into your application.
Okay, perfect. And how would that look? Let's say Log4j was a great example of this. So it's a thing that it's not directly in the application, but the application is using it. What would that look like? What would the experience be like? Like, where's the developer seeing that? What does the recommendation look like? And how does that go into their workflow?
Yeah. So Log4j was obviously like a huge event in the industry, involved a lot of teams. I'll start with the security experience, and I'll show you how security can design that experience in a way that doesn't interrupt developers. So as a security team, I'd log in, I'd look at my findings, I'd see a critical finding for Log4j, or in this case, maybe I need to go search through my environment and find all the instances. What we'll do though is you can find where it is, so which applications, et cetera, are using it. But then I can dive into a particular application and actually see, is the vulnerable function in Log4j actually used in my code? Best case, we might be able to give you some evidence that, in fact, you're using the Log4j dependency, but your application code isn't using that vulnerable function. That means, all right, you might want to update this anyway, but it can be a lower priority versus this other application that is actually using that vulnerable function. Now, when you're onboarding the Endor Labs platform, you can actually decide how this surfaces for developers using our policy engine. And so in this case, you might say it's a critical vulnerability. I might decide I'm going to block anybody from building any new applications with this. So for an example, if I was a developer and I was submitting my pull request, I could, block any build of the application, give them a warning that they need to, fix and upgrade this dependency in the code. That's kind of like the ideal workflow. Or, if it wasn't Log4j, if it was a maybe more minor one, I could say, I'll let you go ahead and ship this production. That'll give you a warning, and you can choose to accept that and continue if you wish. And that's kind of a key difference, is that ability to decide, warn, or block. So you can kind of decide and design that developer experience, not just set some guardrails and move on.
Okay, and you mentioned the IDE, and you mentioned the sort of agentic stuff. How does that materialize?
Yeah, so I'm sure your audience has heard about the Model Context Protocol over the past year, MCP. So that is a way of integrating systems like Endor Labs directly into the agents that developers are using when they're writing code. And so with the Endor Labs MCP, you get actually full access to scanning both for the code you write, any secrets that might be exposed in your repo, as well as what we've been talking about, open source. So CVEs, as well as malware that can also show up in the supply chain. So that's kind of the easiest integration. And the way it actually works is it's completely invisible to you as the developer. Once it's installed and set up, you just kind of work as usual with the agent. And every time the agent adds a dependency or modifies your code, it'll actually do a quick scan to make sure that whatever changes has made are secure. And so this is an easy way to resolve a bunch of security vulnerabilities before you even do that commit or open that pull request. And so it kind of keeps things moving forward and is mostly invisible to developers. Obviously it's there, so you can also choose to run it if you just want to do a final check before you, submit your pull request or a commit.
Okay, so it's kind of active during the development process.
Yep, absolutely.
And it can see the repo, so it can kind of go through and do a scan there. And then talk about the container pieces, right? Because it could be sitting on like this very old container, and like you've done all this work around the code that you're building, but it's sitting on a very nasty sort of thing. What does it look like in terms of like recommending like a more secure version of the container or something like that?
Yeah, so on the container side, we do a little bit different approach, geared more towards the security team as well as the platform engineering team. In most enterprises and companies, it's not the individual developers who are responsible for the images. It's the platform team that's maintaining those golden images. And so what you can do as that team is I can see all of the container images in my environment, all the ones that might be in my registry, etc. And then I can also see all the derived images, right? So I have my golden image, and then I can see, the 5 application images that come off of it, just as an example. And so what I can then see is like, okay, there is this vulnerability, let's say in one of the libraries that's used in the container image I'm using, like let's say it's a Python image that I've kind of built. So I can see, there's this vulnerability in that container image layer. And then I can actually look across those applications and see, okay, either, maybe none of my applications are using it, which case I can just prune that dependency out. I don't need it at all. Or I might see, okay, there's this one application that's impacted because it's actually using that code. And then I can make that decision, okay, should I go ahead and upgrade it? Or do I need to, temporarily put another mitigation because that upgrade might take a lot of work? I touched on this earlier, but we have this concept of upgrade impact analysis. And so that's using that static analysis to actually see, when we build that call graph of your application, are you using that vulnerable piece of code? And then when the maintainers fix it, does that impact your application? Because a lot of times they might modify a function or a class or an API in the dependency. And so we actually give you that visibility so you can prioritize, exactly what you need to go kind of refactor in your own application code.
Yeah, interesting. That's really important because, you can make a tweak and suddenly the rest of the stack doesn't work or whatever.
Yes. Yeah. And it's a huge waste of time, a developer to have to figure out what was the line change and the dependency that I was using and how do they modify it. It's a bunch of reading and research, and then I have to go try different variations to work around it. And we give you that information. So even if it is work, you see exactly what work you have to go do. You don't have to go do that research yourself.
That makes sense. And what type of interaction is there for those other teams? Like, what does the portal look like? What does communication flows look like? Because there's also kind of a friction there if the developer is having to then go and market to the platform team, right? So is it possible to get the platform team involved and kind of be visible in this process in some sort of way?
Yeah. Are you thinking specifically about the container images again?
Yeah.
Yeah, absolutely. So I think one of the cool things about Endor Labs is we actually don't have the concept of like a user account. It is fully integrated with like your enterprise single sign-on systems. So all you have to do is, grant the platform engineering team access, and they can immediately get all this data or pull it into any of the systems they're using, because we're also built fully API first. So again, easy to integrate to wherever this work is happening, give that data exactly where it's needed, allow them to work with it. And so that's kind of the powerful thing is you can build workflows any way you want. Some of our customers actually run Endor Labs basically headless. If you were a developer, you would have no idea you're using Endor Labs because it's fully wrapped into other systems that you're using. And even the security team can roll it up into other things. And so it's this operational layer that you could choose to ignore. Other teams like the dashboard and then choose to use that as their main kind of like interface for working with, security teams kind of managing things and then making sure tickets get cut to, Jira or whatever system that you're choosing to use. But even in that case, like the big benefit, we had one customer in the financial services space that basically reduced their security ticket backlog by like 90% in the first day, right? They went from I think it was like 1,200 tickets down to like a couple hundred pretty much overnight. And, that's a large team with thousands of developers. So that means the huge time savings for them.
And is that just because they realized the things didn't apply to them and they were able to just reply back and say, hey, we're not even using this version? Or
well, in the case of the security team is like, it's you're either not using that version or you're not even using that vulnerable function. And so you can say, yes, there is a risk in this code, but it doesn't apply to us. And so we don't, as a security team, we don't need to flag this as a challenge to engineering. We'll just next time they upgrade the application as part of the process, it'll get fixed. It's not an emergency. Actually, we're one of the only companies that's accepted in FedRAMP. If you're familiar with with FedRAMP, the compliance.
Yeah, I am, yeah.
For selling to the federal government. There's really strict SLAs around, critical vulnerabilities you have to fix within 30 days, or you have like a, 60, 90, 180, depending on the standard. But we're actually auditor approved. You can use our reachability analysis to actually classify something out of that 30-day SLA into some of those longer SLAs, because we can give you the evidence that that vulnerability is not reachable in your code. And so that's how it helps the FedRAMP, but also even if you're not FedRAMP, it gives you that confidence that, you don't have to actually worry about some of this risk.
Okay, so it sounds like a big theme here is this evidence chain indicating like, this is how we know you're vulnerable. This is how we know you aren't. And providing that to a security team or an engineering team or an auditor or whoever.
Yep, that is the big thing. And that's like one of the benefits I think customers love is that transparency, right? So all of that data is accessible to you in that platform, and then you can take it anywhere that you need. So whether it's, we've talked about developer workflows into auditor reports, roll-ups, up to your board or whoever you're reporting to. Besides reporting out the overall risk of the organization, you can actually, again, have that evidence exactly where you need it. And so, we've talked about dependencies. You can see that chain from your code down through, the 5 different dependencies. Or if you're, working on, application code, source code, you see the data flow, like function to function, how something is exposed. We haven't talked about it much, but we also understand additional context, right? So in the, SAST or first party code use case, besides, typical, multi-file analysis, things like that, you could also provide context about how applications work with other systems. And so that we're able to understand that, okay, I'm using this, first party code sanitization library. And so as long as that exists, I can actually say, okay, this code is fixed, and that helps me reduce false positives in my first party code as well.
Oh, interesting. And how about recommendations of like, hey, you should be using this first party sanitization system as opposed to the one that you're using?
Yeah. So we, I think there's 2 aspects to that. First is like, let's say I have a, exposed function I need to fix. We can recommend that upgrade. But then for many companies, there's actually like a standard library that they want people to use. And so that's where you can actually customize it by adding a prompt into the system. Like every application must be using this library to perform this function. In this case, input sanitization. And the system will actually look for that. And so that's kind of where it starts to bleed into like what engineering would call code quality, right? Like I'm doing the things that my organization needs to do.
Yeah, and of course the quality bleeds into security when the thing being recommended is not just a design, but actually a security issue, right?
Yeah, exactly. And I kind of like the way we kind of see the market going is just like more and more security and engineering, particularly in the AppSec space, are going to become a lot more aligned. And our hypothesis here is that, over time, while we'll still have compliance frameworks and things that, companies are trying to maintain, security will become a lot less about checking the compliance box and more about integrating and kind of building that, secure by design system for developers and agents. So they don't have to really think about security. You just kind of build the thing you want to build, and security is baked in.
Yeah. So I very much believe that. Yeah. My friend Caleb Sima has always said security eventually gets eaten by engineering. My example of this is you go on site where someone's building a skyscraper and you ask, hey, cool, who's the department here responsible for the building not falling down?
Yep.
There just isn't one. Like it's built into every part of the schematic, right? It's just the materials that we use, how we set them up, the order in which we build. And it's like, it's just part of the SOP. This is how we build software. Yeah, I think that's really cool. So what does some of that look like as we start to have more and more of the code written by agents themselves? What type of information context here with the tool itself can we provide to the agents so that when they're building, honestly, this has happened way faster than I anticipated. I thought this was going to happen. I didn't know it was going to happen like now, where the developers are like, here's what I want, make this. And it just starts building. So how do we provide your tooling and all that extra context you were talking about to the agents themselves so that they're building safely in the first place?
Yeah, actually, this is like, I think the most exciting opportunity in security. I think, last year, or actually about this time last year, everybody was freaking out about AI generated code and like, is it secure or not secure? As we've seen how the development process is changing, there's actually a real opportunity to do some context engineering for security, right? So that's kind of alluding to like engineering that context. And so, I was actually talking with a lot of our developers this week and over the last few months. It actually starts at the prompt, which is, you think in the past, I would have my design specs document, for example. I might have some security in there. At some point, I might have had a security team review it. But now that prompt is basically that document where I actually kind of outline what is the feature I'm building, what are the specs that need to be built into it. And then the agent goes and builds builds it. So that's kind of the first step. And there's a ton of research here. Even just saying like build, write secure code improves the agent right away, but you can actually go much further than that, right? And you can guide it like you need to avoid this use case or put these controls or even pass these security tests. And so you kind of outline that, give it to the agent. That's kind of the next step. Then the agent starts building. And so this is where, we were talking earlier about model context protocol and MCP. This is the next stage where the agent just needs access to security data. I'm sure most people are probably familiar with how AI, generally works, but I think we often forget that it's trained on open source code, which is an unlabeled set of code that has vulnerabilities baked into it. And so there's actually been a lot of research. There was one from Carnegie Mellon University recently that ran a whole bunch of benchmark tests and found that only about 10% of code from agents is both correct and secure. And so this is the opportunity with context engineering, is actually helping these agents write that secure code by default when developers are, splitting and running multiple agents in parallel with, Claude Code or whatever system they're using. So again, that's where MCP comes in. So the way it works is, besides the access to the backend system, also ships with some kind of built-in skills or rules, which are basically just prompts that guide the agent. Once it finishes a step, maybe it's written your first party code, it should run a scan just to kind of see the code there, or if it imports a dependency to scan that code as well. And so this happens really, really fast, kind of in the back end. If you have an agent running for, I don't know, maybe it's working for 2 or 3 minutes, having, a scan for 30 seconds of that isn't a big addition. That actually helps the agent correct itself. And hopefully what you get is pretty much secure by default, right? It's at this stage, the bias is to move quickly. We tend to find, anywhere from like 80-90% of vulnerabilities, whether it's in your first party code or the dependencies, get fixed at that stage. The challenge, I think, over the past year, though, for a lot of teams has been code review, right? That kind of next step where I'm reviewing the code myself as the author that's now reviewing the agents, or I'm sharing it with my team. AI pull requests tend to be much, much bigger. And then AI fails in ways that humans don't. Particularly, it makes silly mistakes, but these often show up as business logic or architecture flaws. And this is kind of where code review starts to be really important, and actually where it sounds controversial, but actually using AI to enhance it actually helps.
No, I totally agree.
Yeah. So we actually have a product called AI Security Code Review, but what we're looking for there are those business logic and posture flaws in addition to, the standard, SAS secrets, SC, all the stuff we've done in the past to kind of see when these design flaws have creeped in. And so you can review whether this is a business logic, could be like an authentication flaw, or it could be a prompt injection, whatever it is, but finding that, flagging it in the comment, and then helping developers review it. And so we've working with several large enterprise companies. Dropbox is one example I can cite that's actually now using this in their engineering organization to find these types of flaws in their code. So that's kind of the next stage. And then finally, obviously we go to build, and that's where I think all of our traditional stuff still comes in, right? You're still going to CI. This is when we kind of do your typical, deep scan with SAST, SCA, container. But at this point, most things are fixed. And so hopefully you're actually able to keep shipping pretty quickly because there shouldn't be that much that's caught at the CI point anymore.
Yeah, that makes sense. So what does that total flow look like? What are the different product pieces and where do they go in the phases?
Yeah. So again, the MCP is an integration. So you're getting the whole platform there. So you're getting code scanning with SAST, open source dependency scanning with SCA, secret scanning for any exposed secrets, and then also malware, which has been another kind of big challenge over the past year, is the number of malware attacks targeting developer machines. So that's kind of that first stage. Then at the pull request, that's where we do that code review. This is also where you can maybe start to enforce some gates around maybe SAST or SCA as well. If there's, I would call it like regular flaws for code or SCA. And then, full platform, most people use us in CI just because that's kind of like the last big check for security teams. And then there's actually another part that we haven't talked as much about, but like post deployment, we might do a weekly deep scan of your entire repo, for example. The other, I think, exciting part that we didn't talk about is actually burning down the security backlog, right? So with tools like, GitHub Copilot or Claude, you can actually use that MCP server to actually kind of fix things after the fact, because, CVEs and open source dependencies, they're already deployed in most cases. And so some of our forward-leaning security teams, I'll just use Cursor as an example, they're actually using Endor Labs. The security team just fixes everything themselves because they don't want to stop engineering from shipping. And because the volume is so much lower, that they're able to find, prioritize, and then kind of fix in the backlog on their own. And so that's kind of, I think, also where it's going, is as security teams get more technical and more comfortable using these tools, security can be the one that actually applies these fixes in some cases rather than engineering.
Yeah. And ideally, I think what you're talking about there is they're recommending changes that will just apply, like updates to the golden image, right?
Or upgrade the dependency in the application layer. Yep.
Or a new library or an expansion, improvement of the library that would make it better. Yeah, that makes sense. And that just propagates forward. And I like your point about looking at the whole repo, because it could be that, okay, we're starting this new project. We've got this new Endor Labs tool, and that's going to be fantastic. What about the other 940 projects that are already in there? So yeah, you got to look at those. Talk a little bit about like the way it actually gets integrated. So are we talking about hooks like in Claude Code? Are we talking about like a system prompt? Like how does the normal flow of the agent harness tap into and use? Obviously it has access to the MCP, but a big trick is like, how does it know when to call it and what to call it for?
Yep. Exactly. So we actually use both. We have hooks as well as the MCP server. The other way we're actually packaging it more and more is with skills, right? I think that's something that Anthropic pioneered, but it's getting adopted by the other providers as well. So basically it comes with, here's a whole bunch of different commands that you could run, kind of when and why you would run it, packaged with some of those like basic rules that I, mentioned a little bit earlier, but basically like, okay, you've imported a dependency. That means you have to run the scan. And so it's kind of built into the agent framework much more directly. It's not requiring a developer to remember it. And I think back to a year ago, like when MCP was new, one of the challenges I often found is that I would have it there and then the agent would forget to use it, even if I had the rule in the repo. And so like the way hooks and skills work, it's much more integrated. And so, it actually happens now consistently rather than having to be a little bit scattershot, or have to remind the agent that it's supposed to run when it scans.
Okay, cool. So an install would be something like, install the MCP, install the skills. And in Claude Code, for example, when you start up, it's looking at that skills index and it's got triggers in the description field, use when, right? So it's able to pull those up. And then I guess you can have all your system prompts and your MCP calls and stuff inside those skills.
Yeah, exactly. And we were actually a launch partner with Cursor when they announced their hooks. And so we're extending it. But the very first one we built for that ecosystem was actually around malware, because increasingly developer workstations are that target of malware. And so, again, that really taps in, as soon as I do that prompt and the agent starts to perform a task, in this case, pulling in a dependency, it actually goes back to Endor Labs, double checks the dependency, confirms there's no malware in it, and then installs it, and it happens, seconds or less than seconds. And so again, that's kind of built in. Like once you have that installed, you don't even kind of know what's happening. It just happens before the dependency is even recommended or lands on your machine. Kind of happens in the background for you.
Yeah, that's fantastic. So what do you think this is sort of heading towards? If things keep going in this direction, like what does this look like? How do you get more integrated into things? What does that user experience start to look like when it's completely hands-off? Like even, CI and everything is more hands-off. The code review starts being more hands-off. Like how do you get more touch points into the system? Maybe the integration with the organization, maybe making that more fluid. Like what do you see as the opportunities to just make it even more smooth?
Yeah, I mean, I think it's this, the technology is evolving so fast. It almost feels like I can't predict a year ahead right now, because, a year ago, I don't think we were talking about skills, and now skills are like kind of the new thing this year. And I think even in 6 months, it's going to look different. But the way we're kind of building is our platform now is using all of these kind of technologies that we're talking about to build an application that build on two fronts. One, we were talking about this integration directly into these agent harnesses and things like that. But also, again, we were kind of built fully API first, now extending that to the world of agents, so that also that you as a customer can architect your own agents in the future around this and build your own agents off of our tools and data. So again, still pretty early. A lot of this is evolving right now, but that's kind of the future we're kind of building towards, is that we'll have our agents there, whatever agents you're using, whether that's, the agent in Cursor or in Claude, Code, or, OpenAI Codex, they can interact directly with us. So like the future, you kind of think about it, there's this old concept from the beginning of 2000s called test-driven development, TDD. I'm sure you've heard about in the past. Yeah.
No, I love it. I love it. I use it everywhere.
Yeah. And I feel like it fell out of favor a little bit, but like now it is, I think the way you kind of
it's back,
it's back, right? I write my spec, I write the test, I let the agent go, actually probably a swarm of agents now go run and build things. All those agents have access to that security tooling that my organization has kind of set up in the back end. And I, as a developer, am mainly interacting with the prompt, maybe getting into the code as I need to. I kind of think it's like the way I write now today. Like I do a lot of writing. Most of it still comes from me. If I ask, Claude or something to write something, I still have to edit it. But it's gotten to the point where I'm looking for like adding the human flavor back in, or my ideas. But I think that's kind of where it'll go, is like mostly in the prompt, occasionally get into the code as I need to. And then, it's like a chat experience. It goes and builds it, it tests it, I verify it, check the code review, and it ships. And if I'm a security team, the things in my backlog just keep shrinking. And that's, I think, a world that hasn't really existed. And I think it's actually exciting. Like I think when you talk to most organizations, the risk backlog it's just that. It's a backlog that keeps growing. They, tackle the 2 or 3 things that are most urgent, and then a lot of it doesn't get resolved. But now you can actually burn down that backlog, either tech debt, security debt, and keep shipping in the future. It'll be really exciting.
Yeah, absolutely. Yeah, I love it. I love the idea of what you're talking about, where it's like, well, you can use these agents. We provide them if you don't have any yet. If you do have some, just teach them about this set of hooks and skills and tools available, and they just become a tool set that those agents can use to build.
Yeah, the benefit there again is like because of both our background in static analysis. So that's kind of I was talking earlier about that calculator piece, right? If I ask an agent to like scan and review my whole code base, it's going to be really slow, expensive. Static analysis gives it that, those tools to do the security check really, really quickly, cost efficiently, at scale, right? So that's why we've been testing with some of our largest customers, like Elastic, Peloton, and others that are these huge companies, large engineering teams, so they can kind of build and ship quickly while embracing all these different new AI ways of working.
That's fantastic. Anything exciting coming out? Are you going out to RSA by any chance?
We'll be at RSA. We'll be sharing a lot more. We announced our AI SaaS product back in November. We'll be sharing a lot more about it at RSA, as well as some of the other stuff that we'll be doing around developer workstation security. So where all this agentic work is now happening is actually on that developer workstation, some additional security for that as well.
Oh, really cool. Well, I will be out there. I'm local anyway, so.
Oh, excellent. Well, look forward to seeing you there then.
Yeah, absolutely. Anything else you want to mention? Could you mention where people can find out more?
Yeah, absolutely. Check out endorlabs.com. So obviously it's a security team. There's a bunch of stuff for you there. But if you're a developer, you can try out our MCP server. It's free. You can go grab. We have lots of resources about context engineering for security or, secure prompt practices. So lots of resources. Feel free to check it out again at endorlabs.com.
All right, Andrew, thanks so much.
Thanks, Daniel. Appreciate it. Talk to you soon.
Take care.